marking. So some of you get 1 extra mark. Alright. So as I'm going through this test, if you have questions, sit up straight. If you have questions regarding your own mark, can you please let me know after? I don't want anyone to raise their hand to answer the question just about their mark, because that wastes everyone else's time. Now, first question is 32, right? So it's the total is 3 numbers, 34, 3 times 34, the total is 102. And you know 2 of them are 25 and 45. You have to minus them from your number. So that will give you 32. Second one should be mean. That's because, for the median is somewhere between, somewhere in 36, I think. So if you add 32 to it, it's not going to affect it at all. And with range, it's still going to be from 32 to 40. With mode, it is still 36, right? So the only thing that changes is mean. Question 3, it asks how many students. It doesn't say how much percentage. So a lot of you have the 25%, but that's 25% of the whole group, right? So you do 25% times 112, or else you don't get all the marks. So it should be 28 as your final answer. Question 4. A lot of you didn't even get any marks for this question, to my surprise. What are the actual scores? The scores are on the horizontal, right? 1 to 10. So the range is going to be just 10 minus 1. It's very straightforward. 10 minus 1, so it's 9. And the mode, this is a cumulative frequency graph. You need to find out the actual frequencies, and you will see 4, 6, and 8. They all have the frequency 3. Yeah. So that means the mode there are 3 numbers that are modes. So I guess the question is a bit problematic because it should say find a mode or modes, because otherwise it's a bit misleading. Question C, find the median of pins. How many scores do you have? You have 19 scores. Right? 19 scores. To find a median, n plus 1 over 2, 19 plus 1 over 2. So the 10th number is going to be your median. So 10th number, you go to the graph, it's equal to 5. And the mean, you just have to put in all the numbers with not the cumulative frequency, but the actual frequency. Right? So in your calculator, you need to put in 1, 1, 2, 2, 3, 2, 4, 3, so on and so forth, to be able to find 5.42. Alright, question 5. For this one, your graph, first of all, your line needs to be long enough. It can't just go through 2 points. And you're also not just merely selecting 2 points in these dots. You're trying to find where is approximately the middle of this graph, right? And when you're finding the line of best fit, what points are you supposed to find? Are you supposed to find the points on the line you've drawn, or is it the points on the original scatter plot?
On the line?
On the scatter plot.
This is where a lot of you got wrong. It should be on the line. Everyone should have a different line of best fit, right? Yes?
It doesn't have to be already one of the dots.
It doesn't have to be one of the dots. It has to be on the line you have drawn. On this line, you find like a point, like the points that are sort of at exactly the cross sections, so that you can get the coordinates easily. For me, I chose 5, 10 and 25, 20. So even when I was drawing the line of best fit, I was sort of intentionally letting it pass through 2 cross sections so that I have very clear coordinates. If you didn't do that, that's 1 mark off. And also, in a linear equation, you have the gradient and the y-intercept, m and b. They're either whole numbers or fractions. We never, unless it's a least squares regression line, we never really use decimals in the line. So if you used, say, a decimal, say if you did 7.5 instead of 15/2, I took half a mark off. Because you're not supposed to write like that conventionally. Question 6. First one dependent, second one independent. And it's, for B it's ID and C is DI. The only thing that's like most people got wrong is question B. So the number of people attending a function, the cost of the function. I mean, why would you think the cost is independent? I still don't understand that. The last one, so the fuel consumed by a car in the distance travelled. So are you thinking the fuel, like how much fuel you use determines how far you can go? Because if that's the case, you would think the fuel consumed is independent. But if that's the case, it wouldn't really be worded like this. Because by the way it's worded, it sounds like the fuel has been consumed already. So that's a result of having travelled a certain distance. So distance should be independent. But in a HSC exam, if a question like this comes up, it will definitely be a lot more clear on what it wants you to do. Question 7. So the mode of the distribution is 21. The value of A, you just have to do F times X, right? And then 21.4, I think there's not really any major problems here. The problem is with the graph itself, surprisingly. It's cumulative, so you find the cumulative, you need to use the cumulative column, your graph will definitely go up. And where do you join the lines? You join them at the top right corners, right? So your line should look like this. Some of you didn't do this one correctly. And this is where my answer's wrong. It should be 23. So Q1 is 20, Q3 is 23. So the RQI is 23. I accidentally put 22.5 there, but 22.5 should be down here. So 22.5 should be here. And then it will go to 5 exactly. And I'm sure some of you are thinking where I got 22.5 and the other number from. Because the question says you use the polygon, you need to use, for Q1, it's the top 25%, right? Q3 is 75%. And you have in your set of data 30 numbers. So for Q1, the position should be 25% times 30. This will give you 7.5. And then you go to the graph and you look at where 7.5 is. And for Q3, you do 75% of the 30, which is 22.5. This is where I got these two numbers from. And they stand for the position of your Q1 and Q3. And this only works, once again, if you're already given the graph. If you're not given the graph, you need to use n plus 1 over 2. Okay? So if you're just given a frequency table, that's when you use n plus 1 over 2. And I'm sure some of you just put the whole thing into the calculator and you got 23 and 20. And because this question is only 1 mark, there wasn't any evidence for me to take marks off if you did that. But just make sure, just for future reference, you need to do the percentage thing instead of just putting everything into the calculator. Question 8. First one, which student completed the game in the fastest time? So fastest time would be this person because it's 20 seconds, right? Just the smallest number. Sarah, can you see that please? Thank you. And then the interquartile range for this person is 11 and the other one is 4. And for question 3, once again, like I said, for a question like this in the HSC exam, it will be 3 marks, but for this one, it's just 1 mark. So if your answer is well justified, so if you have provided some sort of evidence for your reason, I'll give you the 1 mark. But just remember, you need to include calculation. And question 9, I was surprised that some of you still got this one wrong. We did so many of these questions, didn't we? And remember how Mariam asked me, some people got English? I think they just accidentally wrote English. The question is science for everyone. But I didn't take marks off if your answer is English is better. Just Make sure that you read the question carefully.
Miss, so is it the lower the Z-score, the better performance, or
The higher, the better.
Oh, okay.
Alright. Next question. Question 10. It's 174. You just have to go to the graph. And then, for question II, it shows a very weak positive correlation. But then, if your answer is, it makes sense. If you agree with the statement, you need to at least tell me there's a weak positive relationship. Or you say as the weight increases, the height also increases. If you didn't say that, if you just gave me some primary school level reason, I didn't give you any marks. And if you said no, possible reasons could be you can choose outliers. So say for this person is very light, but they're very tall. And there's also, say, a point like this. This person is very heavy, but they're not that tall, right? So you can choose outliers to say it, or you can just say everyone's different. Everyone's builds are different. Sorry. Alright, next page. I think no one got these ones wrong. Question 12. This point should be here. So this is what a graph should look like. And if your line didn't pass through approximately the middle, I also took a mark off. Why is it not reacting? Alright, and line of best fit, most of you got this question. For question C, as long as your answers are correct according to your line of best fit, I gave you the marks. So my answers are just like approximately how much your answers should be. And question 13, I already told you before the exam, I need 2 keywords. First one is predicting. Second one is inside or outside, right? If you just said inside or outside, that's only 1 keyword. There's also predicting. You can't just say finding the value. What does it mean, finding? Like this, no. If you're finding the value, that means something's already there. But if you're predicting, that means you're finding something that's not there yet, right? So it's completely different. Question 14. There are 21 numbers, so your median should be 25. And then in the first set, there are 10 numbers, n plus 1 over 2, so 10 plus 1 over 2. It should be the 5.5th number. So that's the average of 14 and 16. Same as for the second quartile, it should be the average of 31, 33. So, yeah. And the interquartile range is 17. Any questions?
Miss?
Yeah?
You know, for the last question, I put it in the calculator and I got that. I don't know why it's different.
Did you put in 29 twice?
Yes.
I think it's because there are 20. Okay. If you put into the calculator, you can only do that if there are 20 numbers.
An even number?
No, just 20 numbers. There are 21, so maybe one of the values got deleted once you put in a 21st number. So be very careful about that.
You know, did you get 24?
Yeah, I got 24 30 because I used the calculator.
For this question, it's meant for you to do it manually. You can do it on a calculator if you did 29 frequency 2. But if you put everything in just as it is, then you're not going to be able to get a right answer because it will only take on 20 numbers at a time. If you have questions about your marks, ask me later, please. Alright, can you just put your test aside first? If you have questions regarding your marks, just let me know in a sec. I'll talk about today's content first. I don't get what you mean.
He said, what's better, being racing or type?
What do you think? Still waiting. So from yesterday's homework, is there any questions? Yes? S? Alright, let's do S first. So with S, what is this big square root? Can I change it into a power? What is the power going to look like? 1 over 2. Right? So the whole thing for S, I'm going to do it on the side. It's going to be so 3x to the power 7 times 12x to the power 9 over 2x cubed. I'm not changing anything yet. But on the outside, the square root, I can change it into 1 over 2. So once I've done that, inside the bracket, there's something I can combine, right? 3x to the power 7 times 12x9. How do I combine? What do I combine? So you do the numbers together. 3 times 12, that is 36. What do I do with the powers for x? Add them up, right? To the power 16. On the bottom, how do I apply the square? You have to apply it on both 2 and x cubed, right? So it will be 2 cubed, that's 4, x to the power 6. And this whole thing, to the power of negative, to the power of 1 over 2.
Why is it to the power of 1 over 2?
Why is it to the power of 1 over 2? Because there's a square root.
Oh, okay.
Yeah? And then this will give you, in the bracket, you have 36 and 4. That means you can cancel out the 4. You'll get 9 left. X to the power of 16, x to the power of 6. You have 10 left. Right? So that will leave you with 9x to the power of 10 to the power of 1 over 2. And then you can apply the 1 over 2 to both things. You can apply it to 9. You can also apply it to 10. How many times have I said it, everyone else? What is 9 to the power of 1 over 2? 3. Right? So 3 x 10 times a half, that's 5. So 3x to the power of 5. You can simplify in the square root as well. It doesn't matter, like there's no order to it. And what else? What else? 2h, this one. So, what does the negative mean? The negative is a fraction. So you can put the whole thing over, 1 over this whole thing first. 1 over 25 to the power of 1 over 2. What is 25 to the power of 1 over 2? That's 5. So you can just write it as 1 over 5. 1h. Now you have division. So what do you do with powers? Minus. So you have k to the power of 2x plus 1 minus. Don't forget the brackets. And minus 3. And then this will be k times to the power of 2n plus 1 minus n plus 3. And then you simplify that. That will be n plus 4. So k to the power of n plus 4. Okay. Can I move on to today's content?
Yeah.
Now in today's lesson, we're just going to finish 3 and 4 from exercise 16H. So the worksheet I gave you yesterday. We have learned quadratic equations, right? Today we're also going to do another type of equations, which is equations with indices. So let's just quickly revise. What is an index? If I say a number is an index, what does that mean?
Power.
It's got a power, right? Say 3 to the power of 5, this is an index. If it's x to the power of 3, this is also an index. But when we talk about index itself more specifically, in a number, say 3 to the power of 5, which part is the index? 5 is the index, right? So whatever the power is, that is the index. Now, if you have two things, two indices being equal, and for these two indices, what is the same? The base is the same, right? If the bases are the same, that means their powers are also the same. Does that make sense? Yeah, it's pretty intuitive, right? So for example, if you have 3 to the power of x equals 9, we know 3 squared is equal to 2. 3 squared is equal to 9. But how do we do it by changing 9 to a base of 3? So 3 to the power of x can be equal to, we change 9 into an index, it's 3 to the power of 2. Now the bases are the same. I can say the powers are the same. So this is why x is equal to 2. If you do it like that. Now the second one, 5 to the power of x equals 1. How would I do it? 5 to the power of 0, right? So always change the base to the same first. And then I can say x is equal to 0 easily. Huh?
Yeah, isn't it like guess and check?
No.
It's equal to 1.
You just have to change the base to the same number. So 1, if I want to change it to a base of 5, it's going to be 5 to the power of 0. Because anything to the power of 0 is equal to 1. Yeah? So 5 to the power of x is equal to 5 to the power of 0. Bases are the same now. I say x and 0 are equal. Same as the first one. 3 and 9, they're different bases. I change 9 into the base of 3. 3 squared. Right? And then I can say x and 2 are equal. Huh? No, you just have to say the powers are the same. X is equal to 2. Like that. You don't have to square anything. Yeah? For this one, it's also x and 0, they're the same. Okay? Alright, question C. 7 to the power of x equals 1 over 7. How do I make the base the same?
7x equals 7.
7x equals 7 to the power of minus 1. Right? Because 1 over 7 is a fraction. That means the power is definitely going to be minus, and 7 is 7 to the power of 1. Isn't it? So if you want to go reversely, then that's going to give you 7 to the power of negative 1. It's the same as any simple fraction. So if you have 1 over 2, how do I write it as an index? 2 to the power of negative 1. If it's 1 over 5, it's equal to 5 to the power of negative 1. So if you have, say, 1 over 2 to the power of 3, how do I write it as an index? 2 to the power of negative 3. You just have to change the power to negative, and whatever power you have on the base, that's how much the power is. Alright, so this gives you x and negative 1 are equal. Any questions? Batu, can you say that properly? Thank you. Okay. Next part. we have 6 to the power of x equals 216. This looks like they're not related at all, right? But can I possibly just think, what can 216 be possibly made of? If a question is given to you like this, obviously I can change 216 to a base of 6. Make sense? But let's just try. 6 to the power of 2 is equal to what? 36. See if I go one further. 6 cubed, how much is it? This is 216. Right? So this is already the answer. So you have 6 to the power of x equals, I just have to change 216 to 6 cubed. Now I can say x and 3 are equal. So the powers are equal. Does that make sense? Shouldn't you copy it? That all? I didn't see your hand moving. You're what?
No, you said should be right as
Let me see.
I didn't write it.
Why not? Alright, question B. 5 to the power of x equals 0.2. What can I do? Marianne? Change the decimal into a fraction first. That's because we've seen surds, so we change surds into an index, and the index has a fraction as the power. We've also seen a fraction changed into an index, and the index, the index is negative. But we've never seen a decimal, right? But it's possible to change this decimal into a fraction. And what's the fraction going to be? 1 over 5. So 5 to the power of x is 1 over 5. And can I rewrite 1 over 5 as an index? What is it? 5 to the power of minus 1. Now the bases are the same. I can say x and minus 1 are equal. Now the next one is sort of challenging at this stage, at least. 32 to the power of x equals 16. Is it possible to do 16 to the power of something? Is it possible to do 32 to the power of something to be equal to 16? Probably not, right? What can we do? Divide? Divide both sides by 16? Square root? You can only square root when? When you have x squared equals something. Do you have x squared? No, x is a power. So you can't square root both sides. What can you do, Ella? Find the highest common factor. So, how do I make the basis the same? We've changed one side at a time for every other question. So here, is it possible to make 32 and 16 into the same base? It doesn't have to be either one of the numbers. Yes, Sarah? What can you do? So 32 and 16, first of all, they're both even numbers. Say that again, sorry? Divide both by 8? You can only divide, so say Ula also said HCF, and I also heard someone else said you can divide both sides by 16. You can only do that if I'm just doing normal numbers. Say if it's 32 times something else. But I have a power here, so you can't do it like that. What is 16? Can I write it as an index? Just any index. 4 squared. But with 32, can I write it as 4 to the power of something? No. What about, with 16 it can be 4 squared. Can it be something else? 2 to the power of 4. So 2 to the power of 4 is also 16. Can I write 32 as 2 to the power of something? So we have 2 to the power of 4 is 16. If we just go one further, 2 to the power of 5, this will actually give you 32. Right? So you can actually rewrite 32 as 2 to the power of 5. And you have x outside of it. Does that make sense? I'm just changing the numbers into indices. So, because I just did something to 32, I didn't do anything to the x yet, right? I just changed 32 to 2 to the power of 5. So I guess it's probably easier if you just remember 2 to the power of 5 is 32. That's something you'll be using very, very frequently. So 2 to the power of 5, x equals 2 to the power of 4. Now with this, can I expand it? I just have to times the powers together, right? So 2 to the power of 5x is equal to 2 to the power of 4. Now I can say the two powers are the same. 5x is equal to 4. So 5x equals 4. Oh, what happened? Sorry. So x is equal to 4 over 5. So when you're given two numbers that they look different, it's possible to change them to the same base. And when they're even numbers, most likely you're going to change them to the base of 2. Any questions so far? Alright. Maybe we'll do one more on that. Let's say if we have a question like 9 to the power of x equals 23 to the power of 2. What do I do? This is just an additional question. What do I do? Can I rewrite 27 as to the power of something? 9 to the power of something? What is it? 3 to the power of 3. So 27 can be 3 to the power of 3. What about 9? 9 is 3 to the power of 2. So now I just have to combine the powers. Right? So you have 3 to the power of 2x. That's equal to 3 to the power of 6. Now I can make 2x and 6 equal. So 2x equals 6. X is equal to 3. So additional question. Yeah. Let's do example 3 first. I think in your homework there will be quite a few questions like that. So practice that. If you don't understand it, we can talk about it tomorrow. But make sure that you try it first. Alright. Question, example 3, first one. So 6 to the power of x equals 6 root 6. What would you do? Put it into fraction first, right? So you have, if a number has, say, fractions and surds, first change these things into indices. Because maybe once you've done that, you can combine the powers and the whole thing makes a lot more sense. So it'll be 6 to the power of 6 equals 6 times, what's square root of 6? 1 over 2. It's 6 to the power of 1 over 2. It's a surd. How do I combine 6 and 6 to the power of 1 over 2? 6 is 6 to the power of 1. Right? Just plus them up. So 6 to the power of x is equal to 6 to the power of 1 plus 1 over 2. So you have 6 to the power of x equals 6 to the power of 3 over 2. Now you can make x and 3 over 2 equal. Let's not worry about question B yet. Let's look at question C first. So for question C, 4 to the power of x plus 1 equals 64. Is it possible to change 64 to 4 to the power of something? 3, right? So you have 4 to the power of x plus 1 equals 4 to the power of 3. Now x plus 1 equals 3, x is equal to 2. I think this is probably something you've never seen before, but hopefully through practice you'll be able to do them because they're not really that hard. It's just a different concept. I think let's not worry about question B yet. If you have tried it, just show me your answer. You can start on questions 3 and 4 now from the worksheet. If you have questions, just let me know now.
How do you get 1 over 2?
It's a square root. So square root means you have 2 on the outside, 1 on the inside. So it's 1 over 2. Right? Huh?
What if it's a cube?
If it's cubed, then this changes to 6 to the power of 1 over 3.
Okay. So tell us because of 3.
Yeah, but if it's 2, it wouldn't write it.
Okay.
Yeah? Does the homework just refer to the examples we've done? So 9 is 3 to the power of 1. So you can change the whole thing to 3 to the power of 2x.
Also, do I put it to the power?
Of 2x equals 3. If you have questions regarding the exam, can you